Alright, so in the previous lesson we installed our pandas data reader library using our terminal, and now we're ready to import it into our Jupyter notebook. So I've actually copied the code from the top of our notebook that imports our pandas library and the Python datetime module. I just decided to copy it here so we can see the full import cell. And after I enter this new pandas data reader option, you'll just want to make sure to execute this cell whenever you reopen the notebook and start again. And again, you can simply write this code in the very top cell at the beginning of your notebook. I'm just leaving it here for easy reference, but as long as you have pandas datetime and pandas data reader imported, all of the methods and functionalities should be available. So the syntax that we're actually going to use for pandas data reader is going to be a little bit different. Instead of beginning with the import keyword, I'm going to begin with the from keyword. I'm then going to write the name of our library, which is pandas underscore data reader. I'm then going to write my import keyword, and then I'm going to write the word data. And I'll explain this in just a second. So this is a little bit of a different way to import a library and also import only a specific chunk or section of a library. So what we're doing here is telling Python that we want to import from the pandas data reader library, but we're not importing the whole thing. We're only importing the data module within it, which is sort of like a little subfolder within it. Now the advantage of this is that you don't have to import the entire library, so you save a bunch of memory space. You just have a little bit more efficiency because you're not overloading the notebook with other things. So we're basically just importing a section of pandas data reader. And the other advantage to this approach could be a disadvantage depending on your typical setup. But what this does is import the module directly into our namespace. So if you compare this to something like pandas, which we import with an alias of PD, whenever we want to call a method within pandas like series or data frame, we always have to do PD dot and then follow it up with that method because everything is stored within the pandas namespace. In this case, data is imported directly into Jupyter Notebook, so we can just reference data dot and so on. We don't have to write pandas data reader dot data dot what we want. We basically just import it directly so and we can use it immediately. The drawback to this approach is that if we have, let's say, multiple libraries and we import multiple modules from within each and they're all called data or they all have, let's say, some kind of duplicate name, you're going to run into namespace issues where whenever we reference data, Python and Jupyter Notebook are not going to know which data from what library you're referring to, and you run into problems. The advantage of using things like PD in the entire library is that everything is self-contained within those libraries and you can't accidentally reference another library. So this approach is a little bit wonky, but it's what the documentation actually recommends for using this. So that's what we'll do, and we'll certainly not run into any issues throughout these lessons. But if you're using any other libraries that have data in the future, just watch out for that. So I'll execute this cell to import. And let's take a look at this data module. So I'm going to type in data. I'm going to add a period and press tab. You can see all of the available methods, and as well as these classes that we can create, and rather objects that we can create from these classes. And the very first option on our list, which is data reader, is what we want. So I'm going to press enter to select it. And this data reader basically queries the internet. It queries an online source for information. In our case, we'll be pulling stock information from Google. So let's go ahead and add our parentheses and take a look at our options. I'm going to hold shift and press tab. And the first four parameters here are the ones to watch out for. We have name, data source, start, and end. So name represents the company that you'd like to pull information for. And the anticipated input, at least in this part of the tutorial, is a string. And that string is not just the full company name, but rather the company's stock symbol, or the little acronym that it has on the stock market. Afterwards, we have data source, which represents what data source we want to pull from. The data reader library offers a variety of options. There's Yahoo, there's Google, there's I think 5 other different ones. We're just going to stick consistently with Google throughout these tutorials. And finally, the start and end parameters allow us to specify the beginning and end of our date range. So that can accept anything from a Python date object to a regular string that's formatted as a date, and it'll be able to figure out what you mean. So to keep things simple, I'm actually going to store all of these arguments in their own separate variables just to buy ourselves a little bit of space. So name, data source, start, and end. Let's create variables. So our first one is going to be the name, which represents the company that we want to pull information for. And let's say I want to pull information from Microsoft. So I'm going to create a variable called company, and Microsoft's stock symbol is MSFT. If you don't know a specific company's stock symbol and you want to look up this information for another company, just go to Google and type in the company name and then stock symbol, and it'll tell you right at the top. And next, our data source is going to be Google. We can write that in later. Let's create our start and end variables and give them a string representing a start and end date. So for the start of our data pull, let's do the beginning of 2010. So I'm going to do 2010-01-01. That's January 1st, 2010. And for the end date, I'm going to pull, let's say, I'm going to pull to the end of 2017, 12/31. December 31st, 2017. And what's great about this is if a date is in the future, and I'm actually recording this in September 2016, if a date is in the future, it's basically going to pull all the data up until that point and up until present day, and then not run into any errors for any days after. So this will allow the code to be a little bit more flexible for future use. Just keep in mind, if you're recording or watching this later in the future, note that your data set may be longer than mine. In fact, it will be longer than mine because you're going to be pulling additional rows for the additional days that haven't existed yet when I'm recording this. All right, so we have our variables. Let's plug them in. So our first parameter here is name. Let's do name equals company. Our data source is going to be Google, and that should be just written in lowercase as a string. That's indicating, again, what online data source we're pulling from. We have start and end parameters, and to them we're going to give our start and end variables. So start equals start, end equals end. And as a reminder, this start is referencing this variable. So some people get confused by using parameters and arguments that are the same, but remember that this is just a reference to this string, and same with this end. So that's why you can write that in. So let's go ahead and execute this. It may take a second. And here you see that we've received a data frame directly from pandas datareader. And you can see here that on the left, as promised, our index consists of a datetime index. So this is a real-life financial data set that you may see if you're working in something like finance or some kind of industry analysis job. But you can see as I scroll down, we have data all the way to the present day. So for me, it's September 16th. For you, it might be longer. It will be longer. So as a result, your total number of rows will be greater than mine. And just to take a look at our columns, we can see that 4 of them are floats and 1 of them is an integer. So we have the open, which is the price when the stock opened at the beginning of the day. We have the price when it closed. We have its high point throughout the day, which is the maximum that it reached, let's say in this case on January 4th, 2010. And we also have the low point, which is its lowest stock price for that day. And then finally, volume is, I think, the number of stocks that were traded that day for that company. So 5 bits of information for us. Let's go ahead and store this in a variable because this process simply queries it, outputs it for us, and once again throws it away out of memory. We need to preserve it in a variable to be able to use it later. So I'm going to store it in stocks and then just preview the first 3 rows so we can take a look at what we have. So there is our data frame pulled from the internet. If you replace this MSFT with any other stock symbol or replace this with any other start and end date, you'll get your own custom data frame, assuming that it can find that stock symbol. So let's take a look at some of our available attributes here. If I do stocks.values, we of course are going to get all of our values for each of those 5 columns in its own multi-dimensional array. We have stocks.columns, which is going to give us the column names, open, high, low, close, and volume. Those are taken right here. We also have our familiar stocks.index attribute. That's going to give us the date time index that operates on the left side horizontally. And just as I promised, it is a date time index. So all of these objects are date times, or internally we can prove that they are, in fact, pandas timestamps. There you can see a sample timestamp for the very first one. And finally, let's just conclude by using the axes attribute. And this is just going to combine the results from our index attribute and our columns attribute, because each of the axes, both the horizontal and the vertical, are placed within this grouping as well, where our horizontal axis, or our date time index, is the 0 index, and our columns represents the 1 index. And here they are structured in their own array, where date time comes first and index comes second. So that's just a quick introduction to pulling data. We're going to be replicating this code at the start of all subsequent lessons. Again, this will not work until you execute this cell. So if you're reopening this notebook, make sure to execute whatever cell you're storing these commands in, and then this command will work, and then it'll pull us our data frame with our datetime index, and we'll be ready to dive into some additional operations that we can do whenever we have an index that consists of datetime objects. So I'll see you in the next lesson.